Welcome to a short lecture on trigonometric equations involving multiple angles. There are new concepts in this section, so we'll just do a couple of examples. And the only difference to previous sections is that now we have arguments of 3x, 4x, 2x within the trigonometric functions. So, one algebra step. 3x equals the inverse tangent of 1. We of course know that the solutions to that are 45 degrees, 200 in the first quadrant, 225 degrees in the third quadrant. It has a period of 180, so then it goes on with 405 degrees, 585 degrees, and so on. The solutions to that will therefore be the 45 degrees divided by 3 and 225 degrees divided by 3 and so on. And since we're supposed to be in radians, that of course then comes out to the 45 degrees is the pi over 4, and then we keep adding 180 degrees, which is pi, hence we have the k pi in there, and then divide the 3 that was in front of the x. And overall, of course, we come up with pi over 12 plus k pi over 3. Next example. Get this a little up here. So solve for theta. This already looks like a quadratic equation. So we'll do a substitution. U equals sine 3 theta. There it is. Then so now we substitute the u in here. So our quadratic equation looks like this. And then it's really easy to factor. You can see that we ought to come up with this expression. And then we put the sine theta back in. The parentheses on the right-hand side is a little easier to deal with. We would come up with sine 3 theta equals 1. That, of course, only happens at 90 degrees with a period of 360. So 90 degrees, 455 degrees, and so on. And then we would have to divide that by 3. So 90 divided by 3 is 30, obviously, and 360 divided by 3 is 120. And that, of course, has the period for which we use the factor k. So there it is, 90 divided by 3 is the 30, and 360 divided by 3 is the 120. The parentheses on the left yields that sine 3 theta equals negative 1/2. The negative 1/2 puts us in the third quadrant and in the fourth quadrant. So we will have two solution sets, so to say. And in the third quadrant, the inverse sine of negative 1/2 would be 210 degrees. Again, with a period of 360, which we have to divide by 3 then. So here's the 210 degrees divided by 3, which is 70 degrees. And then, of course, 360 divided by 3 is 120. And the other solution set, which is in the fourth quadrant, the inverse sine of negative 1/2 will then be 330 degrees, again with a period of 360, and again divided by 3. So we're going to come up with 330 divided by 3, and then of course 360 divided by 3, with the k being an integer number in front of that. And that really was it for this section on trigonometric equations involving multiple angles.